Hello, future chemists, and welcome. Today, we are cracking the code on a topic that is guaranteed to show up on your SPM papers, manufactured substances. And we're going deep, I mean really deep, into one of the most important materials out there, ceramics. But first, before we get started, I want you to grab your phone and scan this QR code. Seriously, do it now. It'll take you straight to the MCQ SPM platform. Why? Because you can practice everything we talk about today with thousands of questions. It's the absolute best way to make this knowledge stick for your exams.
All right, let's get into it. When I say the word ceramic, what pops into your head? Probably a clay pot, right? Or maybe your favorite coffee mug? Yeah, that's what most people think. But what if I told you that the same class of material is used for the brakes on a supercar and inside a jet engine? It's time to forget the pottery class, people, because we are about to enter the high-tech, high-performance world of ceramics.
Okay, so to score full marks, you can't just memorize a few facts. You've got to understand what a ceramic is, right down to the atomic level. This is what separates the A+ students from everyone else. So what is the textbook definition we need to know? Well, a ceramic is an inorganic, non-metallic solid. You basically take compounds made from metals and non-metals, you shape them, and then you bake them at crazy high temperatures. And that heating process is what locks their atoms into this incredibly rigid, super strong structure.
Now, these 5 properties you see here, these are your golden keywords. These are what you need to have in your head for any SPM question on ceramics. So let's run through them. They're hard and strong, they have really high thermal resistance, they're basically heat-proof, they're brittle, chemically inert, and they are fantastic insulators for both heat and electricity.
But hang on a minute. How can something be super strong but also brittle? I mean, doesn't that sound like a contradiction? Well, here's a really easy way to get your head around it. Imagine a perfectly built Lego wall. It's incredibly strong, right? You can push on it all day. But what happens if you give it one sharp whack in just the right spot? It doesn't bend, it shatters. That's a ceramic. The atoms are locked so tightly they can't slide past each other like they do in a metal. And that Lego analogy? It perfectly explains the core science you need for your exam. The real secret is all about the bonding between the atoms. You see, ceramic atoms are held together by a mix of powerful covalent and ionic bonds. It's like they're held together with atomic superglue. And that is precisely why ceramics are so hard and have such ridiculously high melting points.
Okay, let's build on that foundation. It's so important to realize that not all ceramics are created equal. In fact, there's a huge difference between the traditional ceramics, the stuff our ancestors used, and the advanced ceramics that are literally building our future. So on one side, you've got traditional ceramics. These are made from natural clay, and this is where you get things like bricks, tiles, and pottery. But on the other side, you've got advanced ceramics. These are engineered from super pure inorganic compounds, things like silicon carbide. And these are designed for one thing, extreme performance, with properties that clay could only dream of. Just take a look at a modern high-performance brake disc. You might think it's just a chunk of steel, but nope. It's often an advanced ceramic, like silicon carbide. This thing has been engineered from the ground up to handle the insane temperatures and friction from braking at high speeds, without failing, without warping, and without wearing out. It's a total game changer.
And this stuff matters because these unique properties solve massive problems in almost every field. In medicine, for example, we use biocompatible zirconia to make dental implants because they're super strong and they don't wear down. In transportation, they're critical for jet engine components that have to run at mind-bogglingly high temperatures. It's always about matching the right property to the right job. Okay, let's switch gears and get to the most important part of this whole thing. How do you actually use this knowledge to crush your exam questions? It's time to learn how to think like an examiner.
Okay, pay very close attention here. This is a classic SPM pattern. Examiners love these why questions. They don't just want to know what a material is, they want to know why it's the right choice for a specific job. You have got to be ready to link a material's property directly to its function in the real world. Now this right here is the #1 mistake students make, and you are not going to make it. Just writing down it's strong or it's heat resistant is a C-grade answer. I mean, it's not wrong, but it's lazy. It is not enough. To get that A+, you have to go deeper. You have to explain the why behind the property. So here it is, the A+ answer. And I want you to notice the structure here. You always have to link the application, the brake disc, to the key property, its high heat resistance. And then, this is the crucial part, you explain it using the underlying structure,
those strong covalent and ionic bonds. That's the winning formula, every single time. Application, property, structure. Burn that into your brain.
All right, let's wrap this up. It's time for the big picture takeaway, and why all of this matters even long after you've finished your SPM exam. So, just remember this. The very same material that started with our ancestors shaping clay next to a fire is now at the cutting edge of all technology. We're talking superconductors, life-saving medical implants, spacecraft, you name it. Ceramics built our past, and believe me, they are building our future. So the real question is, what will they help us build next? Keep that in mind, and you are going to master this topic no problem.